All right, so before I get started, I just wanted to thank the organizers of the conference for the chance to give this lightning talk. And I also just wanted to say that I'm recording this talk on the stolen territory of the Massachusetts people as a small part of reflecting on the history of colonialism and genocide in the United States. With that being said, so I'm going to talk about annular links. This is a picture of an annular link. We're embedding some number of circles into a thickened annulus. So it's just like a link in S3, but instead we're working in an annulus instead of all of S3. And we can see the annulus in purple here. And I really like to think about these algebraic invariants that take these links and give us some vector space. And so I think nice examples of those are things like Kavanagh homology or knot-Floer homology that you might have heard of before. Because we're working in an annulus, these link homologies have a little bit of extra structure. They have an annular grading. That's kind of remembering we're working in the annulus. And so you might ask kind of, well, what does this annular grading tell us? And for invariants coming from Floer homology, like the knot-Floer homology of the branch double cover, or some version of link-Floer homology or instanton Floer homology, we actually understand what this annular grading means very well. It's kind of recovering the Thurston norm for meridional surfaces. So it's saying something about like the simplest surfaces we can find where the boundary is a meridian for our annulus. On the other hand, for Kavanagh homology, we're not actually sure, but we have this nice conjecture of Host and Shizitsky where they suggest that the maximal non-zero annular grading should recover the minimal intersection number with a disk. And so that kind of looks really similar to the Thurston norm that's talking about how complicated our surfaces have to be. Here we're talking about how many times our disks intersect with the annulus. So we might hope to be able to use some relationship with Floer homology to prove the wrapping conjecture. So we could kind of see, does that work? So in this example we've seen before, there's a minimal intersection number with the disk is 2. And that minimizes the Thurston norm, but there's also another surface that's minimizing the Thurston norm, and it's an embedded torus that avoids our link entirely. But that's okay. That means that the annular Kavanagh homology should be non-zero in degree 2, and that's exactly what the Floer homologies will tell us to. So far so good. But if we look at this example, there's now the minimal intersection number with the disk is 4. But the Thurston norm has stayed the same because there's still this embedded torus that avoids our link entirely. And so that's kind of less good because now the annular Kavanagh homology should be non-zero in annular degree 4, but to the annular Floer theories, they just see, oh, it should be non-zero in annular degree 2, and we see this gap. And I think maybe based on this example, you could probably come up with an example where the minimal intersection number with a disk is like 2000, but there's still this embedded torus. And so we could get this really, really big gap between what annular Kavanagh homology might be non-zero if we believe this conjecture versus what Floer homologies can see is non-zero using the Thurston norm. And historically, these examples come from Matt Hedden and Stefan Verley shortly after Ellie Grigsby suggested trying to use Floer homology to prove this wrapping conjecture. And I think renewed interest has happened since work of Yi Ji relating annular Kavanagh homology and instanton Floer homology, kind of renewed interest in this question of like, can you use Floer homology to prove the wrapping conjecture? And so no one knew if these are even counterexamples to the conjecture. And if you don't believe the conjecture, these would be great places to look because like from the perspective of Floer theory, the annular grading should be really, really low. But from the perspective of this conjecture, the annular gradient should be really, really, really big. So you might want to look here. And this is part of what I did. So I can verify that like this family and lots of other families aren't counterexamples to the wrapping conjecture, even though from the perspective of Floer theories, their annular gradients are kind of trapped in this really small range. But the wrapping conjecture and Kavanagh homology, their annular gradients are growing really, really big. So we see this really big gap between the Floer homologies and the Kavanagh homologies. And the main idea is kind of extending a link splitting spectral sequence of bats and seed into the annulus to use for computations. And overall, this is giving just like lots of good evidence that the wrapping conjecture might be true. And with that, I want to thank you all for your time.